One of the things that you have to be familiar with in the states of matter chapter is called the heating curve. The y-axis is the temperature and the x-axis is the time taken. For simplicity, we're going to use ice, water, and steam as example. From this diagram, we'll see how to interpret it. At first, we have a solid ice, which will be at some negative value here. Once we start to heat the ice will start to gain heat energy. And in this slope, there is a change in temperature, but there is no change in state yet because there's not enough energy yet. Once that ice has reached 0 degrees Celsius, that ice will start to melt into a liquid, where you can see that the solid particles here will gain enough energy to vibrate, and that's when you will be able to see solid starting to melt into a liquid. The melting process in which the solid is changing into a liquid, where the structure is going from the regular lattice structure to the random arrangement, is happening in the horizontal line here. So the horizontal line means that there is a change in state, but there isn't a change in temperature yet. The melting is taking place at 0 degrees Celsius. Only when all of the solid particles have melted into the liquid here, the temperature will start to rise again. As we are heating the liquid particles will increase in temperature until we reach a certain point. At that certain point, the liquid will start to change into the gas, which we can see here. Some of the liquid particles still have intermolecular attractive forces, while some of the particles have broken off their attractive forces and starts to evaporate or boil. When all the liquid particles have broken off their attractive forces and the particles start to move around randomly, then we have a gas here. The temperature at which the solid was starting to melt into a liquid is called the melting point, and the temperature at which the liquid was changing into gas is called the boiling point. So it would make sense to you that solids will have the lowest energy, and only when it has gained enough energy then it will change into a liquid, and only when liquid particles gain enough heat energy then it will change into a gas. Although it is uncommon, sometimes you may be presented with the cooling curve. Now, the cooling curve is almost identical to the heating curve, but instead we'll start off with the gas here. When the gas starts to lose energy, it will reach to a condensation point or the boiling point, where it will start to condense back into a liquid, and that liquid is going to start to lose energy, and when it has lost enough energy, then that liquid will start to freeze into a solid. The melting point and the freezing point of water would always be 0 degrees Celsius, and the boiling point or the condensation point will be 100 degrees Celsius. Comparing the heating curve and the cooling curve, you would see that the gas will have the highest energy, liquids will have a lower energy than gas, but a higher energy than solids, and solids will have the lowest energy. The melting point and boiling point are commonly asked terminologies in exams, so make sure that you learn them. A common exam question about melting point and boiling points is predicting the state of unknown substance if you were given the melting point and boiling point. For example, you're given an unknown substance A, and it is said that it has a melting point of 90 degrees Celsius and a boiling point of 360 degrees Celsius. So is A a solid, a liquid, or a gas at room temperature? Now, room temperature is somewhere around 20 degrees Celsius to 25 degrees Celsius. The trick that we're going to use is by drawing something like this. Now, the boiling point for any substance is going to be higher than the melting point. That's why the boiling point will be somewhere here, and the melting point will be at a lower place than boiling point. Boiling point is 360 degrees Celsius. Melting point is 90 degrees Celsius. Now, if it is at room temperature, which is 20 to 25 degrees Celsius, it means that the substance is somewhere below the melting point. And if a substance is at room temperature, which is below the melting point, then substance A will be a solid here. It means that substance A has not been melted yet, so it's still in the solid state. For our next example, let's take a look at substance B, which has a melting point of -197 and a boiling point of -45 degrees Celsius. So we're going to put them on the temperature line as usual, and the boiling point is -45 and melting point will be at a lower place, which is 197 degrees Celsius here. Now, at room temperature, which is 20 to 25 degrees Celsius, substance B is somewhere in here. So, if a substance is above the boiling point at room temperature, then it will be a gas. This means that substance B has been evaporated or boiled into a gas because it's above the boiling point already. For our last example, we have unknown substance C, which has a melting point of 5 degrees Celsius and boiling point of 66 degrees Celsius. C at room temperature is somewhere in 20 to 25 degrees Celsius, so it's between the melting point and boiling point. So, if a substance is at room temperature, which is between melting point and boiling point, then substance C would be a liquid. This means that substance C is a liquid because it has been melted because it's above the melting point, but it's still not a gas because it's still below the boiling point. Purity of a substance can be determined by looking at the melting points and boiling points. Impure substance such as dirty water here would have a range of melting points and boiling points. Specifically, an impure water will have a higher boiling point than normal water and a lower melting point than normal pure water. The keyword here, if you're asked about the melting point and boiling point of impure substance, is this word here, which is range. They will have a range of melting point and boiling point. For example, impure water would have a boiling point which ranged from 99 to 101 degrees Celsius and a melting point which ranged between 0 degrees Celsius to -22 degrees Celsius. So it's not an exact value, it could be a number anywhere within these ranges. Pure substance or pure water, for example, will have an exact or a well-defined melting point and boiling point. If a water is truly pure, then the boiling point will be 100 degrees Celsius and the melting point will be 0 degrees Celsius. The key word for pure substance is either exact melting point and boiling point or well-defined melting point and boiling point. Pure substances will not have a range of melting points and boiling points, unlike the impure substances. That's it for today's lesson. Like the video if it was helpful to you, and I'll see you all in the next video. Bye bye.